Hi everyone! In today's lesson, we're exploring angle pairs. Our objective is to identify special angle pairs and use those relationships to find angle measures. So first, let's identify the special angle pairs that we're going to be talking about. First, we have adjacent angles. Adjacent angles are two coplanar angles with a common side, a common vertex, and no common interior points. Notice our drawings over here. Angle 1 and angle 2 have a common vertex. They both come from the same point here. Notice that they share a ray. This ray is a side of both angle 1 and angle 2. They have no common interior points. There's no point in the interior of angle 1 that's also in the interior of angle 2. In other words, they don't actually overlap each other. Basically, adjacent angles are two angles that sit side by side, and they share a common side. Vertical angles are two angles whose sides are opposite rays. Notice in this picture, angle 1 and angle 2 are vertical angles. The rays that form angle 1 and the rays that form angle 2 are opposite rays because they form straight lines. An easy way to identify vertical angles is to look for an X in a picture and identify two angles that are across from each other. Notice angle 3 and angle 4 could also be called vertical angles. Next, we have complementary angles. Complementary angles are any two angles whose measures have a sum of 90 degrees. Complementary angles can be adjacent. For example, in this picture, angle 1 and angle 2 form a right angle. That means that they are complementary. But in this picture, we have angle A and angle B. Angle A and angle B are not adjacent to each other. But if we were to add 47 degrees plus 43 degrees, we would notice that that's a sum of 90 degrees. So angles A and B are also complementary. Now let's look at the next definition. Supplementary angles are two angles whose measures have a sum of 180 degrees. Notice angles 3 and 4 are adjacent angles, and they form a straight line. That tells us that angles 3 and 4 added together would be 180 degrees. We could also say that angles B and C are supplementary. Notice angle B is 43 degrees. Angle C is 137 degrees. If I add them together, that's 180 degrees. Use the diagram to determine whether the following statements are true. Explain. So letter A says angle AFE and angle CFD are vertical angles. Sometimes it actually helps to trace the sides of the angle. So angle AFE would be this angle on the left that's 62 degrees. Angle CFD is on the right. Notice that angle AFE and angle CFD form an X. We also notice that the rays of angle AFE and the rays of angle CFD are opposite rays. FA and FD are opposite rays. FE and FC are opposite rays. So these are vertical angles. So yes, the sides are opposite rays. Now let's look at letter B. Letter B says angle BFC, which is the angle that's measured 28 degrees in this picture, and angle DFE, which if we trace DFE is at the bottom, and that's 118 degrees. Angle BFC and angle DFE are supplementary. Supplementary means adding to 180 degrees. So let's add 118 plus 28. And we can already see that when we add 8 and 8, we're not going to get 180 degrees. So letter B is no, this is not a true statement. The sum of the angles is not 180 degrees. Now let's look at letter C together. Letter C says angle BFD and angle AFB. I'm going to use a different color so that we can see the difference between the two angles here. Are adjacent angles. If we notice here, the two angles actually do lie side by side, and FB is a ray on both of the angles. So that means that these are indeed adjacent angles. Yes, they share ray FB and the same vertex. So these are adjacent angles. Now when we're looking at pictures in geometry, we find that there are some things that we can assume to be true, but there are many things that we are not allowed to assume. For example, we can assume, if we are looking at a picture, that any angles that look like they are adjacent or next to each other truly are. We can also assume that angles are supplementary. In other words, if they're next to each other and they look like they form a straight line, then they do actually make a straight line and they're 180 degrees. We could assume that angles are vertical angles. What we cannot assume that angles or segments are congruent, unless there is some information or a marking in the diagram that tells us that that is the case. We cannot assume that something is a right angle unless we have the marking in the picture that shows us that it's a right angle, or they tell us that it is a right angle. And we cannot assume that angles are complementary. This goes back to the fact that we cannot assume right angles. So let's look at this picture. It says, can you make each conclusion from the information in the diagram? Explain. So looking at letter A, it says segment TW is congruent to segment WV. I notice that segment TW and WV are both given the same marking. This is meant to show me that these two segments are congruent. So A is yes, and the reason is they are marked congruent. However, if we look at letter B says PW is congruent to WQ. Notice, there is nothing that tells us that PW and WQ are the same length, even though it appears that they might be. We cannot assume this to be true, and the reason is they're not marked congruent. Letter C says angle TWQ is a right angle. Again, as we look at this angle, it appears that this could very possibly be a right angle, but there is no symbol that tells me that it is. So I cannot assume that to be true. So no, it is not marked as a right angle. Keep in mind that if something were 89 degrees, or 89.5 degrees even, it might appear to me that it was a right angle, even though it's not. Our last example, letter D, says that segment TV bisects segment PQ. Now this one can be a little tricky. If I say that segment TV bisects segment PQ, I mean that segment TV cuts segment PQ in half. In other words, segment PQ will be divided into two equal pieces. This segment is not marked as being divided into two equal pieces. So again, I have to say no. And the reason is I do not know that PW is congruent to WQ. So PW is not marked congruent to WQ. Now, if this statement had been written backwards, for example, if it had said segment PQ bisects segment TV, that would have been a true statement because PQ does cut TV in half, and the reason I know that is that TW and WV are marked congruent. Our next definition is a linear pair. Remember, in algebra, linear means line. A linear pair is a pair of angles that makes a line. The correct definition is a pair of adjacent angles that form a straight line. In other words, you have an angle and then another angle that's adjacent to it. So these two angles are going to share a side. And when I put them together, they form a straight line, or 180 degrees. Notice these two angles both come from the same vertex, and they both share this side. Postulate 1.9 says if two angles form a linear pair, then they are supplementary, which of course this makes sense because if they form a linear pair or a straight line, then they must make a straight angle. And two angles that make a straight angle would add up to 180 degrees. In our next example, we notice that it says we are to find the measures of angle KPL and JPL. We know that these two angles make a straight line, which means that the total of the two angles is 180 degrees. So we could write an equation that says that the two smaller angles, 2x plus 24 and 4x plus 36, can be added together to equal 180. We combine our like terms, giving us 6x plus 60 equals 180. If we subtract 60 from both sides, we have 6x equals 120. And when we divide by 6, we find that x is 20. Now we need to find the measure of each angle. So the measure of angle KPL is 2 times x plus 24, or 2 times 20 plus 24. 2 times 20 is 40, and 40 plus 24 is 64 degrees. So the measure of angle KPL is 64 degrees. The measure of angle JPL is 4 times the x value plus 36. So 4 times 20 plus 36 is 80 plus 36, which is 116 degrees. The measure of angle JPL is 116 degrees. I know this is a reasonable answer because when I add 116 plus 64, I get a total of 180, which is a straight angle. In our next example, we see that angle ADB and angle BDC are a linear pair. In other words, they form a line, making them a total of 180 degrees. The measure of angle ADB is 3x plus 14. The measure of angle BDC is 5x minus 2. Since these two angles form a linear pair, I know that if I add them, they will equal 180. Again, I solve the equation by combining like terms, giving me 8x plus 12 equals 180. I subtract 12 from both sides, giving me 8x equals 168. I divide by 8, and x is 21. Now, to find the measure of each angle, I substitute my x value back in. So the measure of angle ADB was 3x plus 14, or 3 times 21 plus 14, which is 63 plus 14, or 77 degrees. So the measure of angle ADB is 77 degrees. The measure of angle BDC is 5 times the x value of 21 minus 2, or 105 minus 2, which is 103 degrees. So the measure of angle BDC is 103 degrees. Again, I can add the measures of these two angles together and see that when I add them I get 180 degrees, which would indeed mean that those are a linear pair. Our next definition is angle bisector. We actually discussed this definition a little bit a couple of sections ago. An angle bisector is either a segment or ray that divides an angle into two congruent angles. In other words, if you have an angle and then you have a ray or a segment that cuts this angle in half, then that ray or that angle is the angle bisector. So in this case, this ray right here would be an angle bisector if it cuts the larger angle into two equal angles. In this example, we notice that ray AC bisects angle DAB. In other words, ray AC cuts this angle into two equal angles, meaning that the two smaller angles are the same. So if angle DAC is 58 degrees, then angle CAB must also be 58 degrees. So the measure of angle DAB is simply 58 plus 58, or 58 times 2, which is 116 degrees. So the measure of angle DAB is 116 degrees, which is letter D. In our last example, we see that ray KM bisects angle JKL. In other words, ray KM cuts angle JKL into two equal pieces. If I draw a picture of that, I have an angle with K in the middle and J and L on the two sides. Ray KM cuts this angle into two equal pieces. Notice that angle JKL is the larger angle, and it's 72 degrees. So JKM must be half of that. Or in other words, I simply need to take 72 and divide it by 2 to get 36. So the measure of angle JKM is 36 degrees. And this is the end of today's lesson on angle pairs.